this video we'll be talking about sonar. So what's sonar? Well, essentially here we're talking about a time of flight. So we're measuring the time it takes for something to travel. And in this case, it's sound or ultrasonic sound. We typically use ultrasonic sound because we don't want to disturb the environment around us by people who are like, what's that noise going on all the time as you're trying to do these measurements? So we use an ultrasonic sound. It's outside our range of normal human hearing. So essentially what we do, we send a pulse. That pulse is bounced back off an object, and we measure the time it took for that pulse to go there and return. And based on the speed of sound, we then know what the distance that object is away from us. And so we can use that simple formula that we learnt in year 11 physics, or probably even earlier. Distance equals time times velocity. And in this case, we need to divide it by 2 because we've got the distance of traveling to that object and then the distance coming back to that object. So we've got double the distance there. We can base that on a speed of sound of approximately 0.3 meters per second. We can work out how far an object is away from us based on sending and receiving those sound waves. So a bit more technical detail on it. There's lots of different rangefinders around. Ones like this simple one here, these are very low cost and have 2 transducers on them. To more expensive ones, this particular one's a waterproof one that has the sender and receiver transducer built in together. They have frequencies that are 26 kilohertz to 215 kilohertz, so higher than our typical range of human hearing. And our range is typically less than 10 meters. At that sort of range, we've got a whole lot of interfering signals and interfering noise, and we've got getting less of a signal being bounced back to us. There might be a few rangefinders that do slightly more than that, but not many out there. Accuracy over that sort of range is about 1 centimeter. So not super accurate, but really pretty decent, depending on what our application is. If we're using it to try and work out how to park our car, 1 centimeter is actually quite adequate because we probably don't want to park that close to a wall or something like that. Likewise, if we're navigating our robot around. Likewise, if we're trying to move a robot parallel to a wall that we're doing condition inspection for or something, 1 centimeter tends to work fairly well. Sonar's got a wider beam width, typically in the region of 30 to 40 degrees, something like that, which means anything within that region, within that radius that bounces back will be measured as there's an obstacle there, something's bounced back. Now, sonar is fairly cost effective, so we're looking at $10 to $100 depending whether we want the waterproof versions. And you can see here the signals that are sent out by that sonar. So we have the sonar signal that's sent, and then we have the echoes of that signal as it bounces back and is received back. Sometimes we'll have multiple echoes because we might have multiple objects that's bouncing off or multiple walls that's bouncing off. For example, if we've got that chair leg and we've got a wall behind it, it'll bounce off the chair leg, and then some of the sound will bounce off the wall behind it as well. So we're really looking for that first echo that we receive because that's the closest object. So in terms of the advantages and disadvantages of our rangefinders, well, they're fairly simple to operate, where we just need to do a bit of timekeeping. Depending on the type of rangefinder, some have a whole lot of signal conditioning built into them. Some, we basically send a signal and set a pin to go high and say transmit, then we wait and count how long it takes for that pin to go low or high for us to say, oh, we've received that value back again. It does basically straight line measurements, so we don't have to measure or send a signal from here and receive it over here, so we can do a fairly straight line measurement. Some of the other systems we'll be looking at in a bit use something that's more based on triangulation, where we don't have that straight line measurement. And we have that wider beam width that can be good for obstacle avoidance, because if an obstacle is quite small, it could potentially be missed by a point source LiDAR. And so it can detect some of those things and detect obstacles that might form in our path. The accuracy of the rangefinders, these ultrasonic ones, tend to be fairly good as you increase the distance up to its maximum range of 10 odd meters. And the reason being that some of our rangefinders, like when we're using stereo vision or when we're using triangulation-based sensors, we've got this triangle, and it's a lot harder to accurately compute those angles when it's further away. We're taking up less and less pixels. But here, we're just waiting a longer period of time before that echo is bounced back to us. Having said that, there are some significant sources of error. One is the differences in propagation speed. I'll address that in the next slide, but propagation speed of sound changes with things like medium and changes with temperature as well. Also, uncertainty in the exact time of arrival. For example, was it 1.5 milliseconds or 1.6 milliseconds it took? Well, we'll need accurate timekeeping on our microcontroller or microprocessor to actually determine exactly when it's bounced off and arrived back. We can also have some inaccuracies with reflections and echo and deflections, where if we bounce off one object and it bounces off another object and bounces off another object and it can bounce back to us, or if it picks up something in the foreground where we're trying to sense the background, there's a few things that can go on there. We could also have crosstalk, where we have multiple rangefinders very close to each other and one sensor is receiving a signal from another sensor. We need to be aware of that. Also, that wide beam, we might have something that's outside our field of interest that we're actually detecting. And our accuracy is about 1 centimeter or so. I mentioned I'd address the temperature element of it. And so we see here 3 different regions, one that's stifling hot, one that's temperate, and one that's very cold. And the speed of sound varies markedly between these. Now, some of our rangefinder modules that we might use, or integrated systems that we might use as a measuring system, will often have a temperature sensor built in. So you can do some compensation for the temperature. When it starts up, it will measure what the temperature is and use the relevant speed of sound associated with that temperature to give you a more accurate reckoning of what your distance is going to be. I mentioned some of those deflection accuracies as well, and you can get things like this. If you bounce it off a wall at an angle that's greater than 45 degrees, you can miss the reflection altogether because that reflection hits the wall and bounces off in a different direction. Or if you hit a corner, it might bounce off in either direction, you miss it altogether. Or you might, there might be something on the other side of that deflection that might bounce off, hit that thing, and then bounce off and bounce back to you. And you've got this false detection of an object that is not in your line of path, but you've missed the actual wall that is not detecting that wall. So there's a few things to be wary of when we're using rangefinders of this ultrasonic type, that they can actually bounce off things and we can miss the return pulse that's coming off there. I mentioned crosstalk as well, and crosstalk, we might have multiple rangefinder sensors because we're trying to increase our beam width a bit. And some of those might be fine, they're adjusted so they don't interfere with each other. But if we're going through maybe a narrow corridor or something, they might be bouncing off separate walls, bouncing off something, and constructively or destructively interfering with each other as they bounce back. So a few things to be wary of with these ultrasonic rangefinders.